left off on the last video. So this is basically a quick start for 3-matic, or what do you do after you've segmented your parts? So as you can see, we've got a mimics file here, and I've got some objects that I've cleaned up a little bit more. I've filled in thin bones. I've filled in areas of bone that should be solid. How do I like check that those are accurate and that I can go forward with the CAD operations? So a radiologist would take a look at these objects. They would probably turn on these contours, which show you the edges of each of the highlighted masks, and they'd scroll through these images and say, okay, making sure the objects are in the right locations, the bone is segmented out, and the contours are accurate. So say, oh, maybe this doesn't follow the gap so much. So you could do some minor tweaks with the contours. I'll just show you a little bit of that. You shouldn't do anything major with this stuff. What I would use to fix this is the magnet tool with a diameter of 10 millimeters, and I would hold Control, right click, and drag up, and you can just draw where's the actual edge of this boundary with the mask selected as maxilla, because that's the active one. So just draw where the edge of that boundary is. Hopefully it will adjust itself. There we go. We have fairly thick slices on this data set, so you have better data. This is obviously works a little bit better. And this is an extra mask, so I'm doing that one off. Just delete it. Okay, so that's how you might edit some stuff. That's how you check the contours. What you do after that is put it into the CAD software, which is 3-matic. So to do that, you need to click on any one of these objects and hit Control C to copy. And you get a little pop-up here that shows you your parts and your masks. And the masks, if you remember, were the marked pixels through the stack of images. That creates voxels, or like 3D pixels. And those get converted to objects, or parts they call them here, and which is a 3D mesh object, which is a surface covered in triangles that encloses some volume. So I want these parts for the CAD operations, the mesh 3D object, and check off all the parts that you want to bring over. Click OK, and just make sure you have 3-matic also open. Click over here in your object tree and Control V to paste. Those objects will come in. If you had them hidden in Mimics, they'll be hidden in 3-matic, so we'll just have to right click and do show for the objects that are hidden. So you wouldn't see the C2 back here. Right click and do show to show. You can do recoloring of all these. That might be a good first step. So hold Shift, select all of them, click selection, click part color. For bone, we use 227, 218, 201 for RGBs. Click OK. If anything doesn't change color, you just drop it down, click surface list, click use weird color, save it. Some operations that we would do immediately after the segmentation here is if you want to keep with the originals for any reason, make sure you make duplicates of it. So Control D on an object to make a duplicate. And you can work with that and just hide your original. You can also make a folder of originals. So you can do right click, create group, call that originals. You can hide that. And then as you make duplicates, you can drag them just into that folder. So say I did mandible, take this one, drag it into originals. Automatically will hide that. All right, so first thing I might do with this is fix the meshes. So I'm going to, from segmentation, you might end up with some mesh defects, which can be overlapping triangles, double triangles, triangles where the normal side, which just says point outward of the model, maybe that's flipped over. So different errors, and you'll see those if you hit Control F when you're selecting part. First thing you do is check full analysis and click follow advice. And you usually have some numbers here. If you see inverted normals, that can relate to a hole on the inside of your mesh. Could be like a pore or something that is actually a hole. And you could see that if you did transparency medium or so. And you do have, sinuses on the inside that may be actual holes. If you want to figure out where those are, you can hit F7, which is a shortcut. F7 or a shortcut to select shell. So you see much. Click the mandible, hit O, inverts the selection, and you see any floating pieces that are in there. That could be holes, or that could be just positive floating pieces. If you don't want those, you could delete them. Just make sure they're not supposed to be there. So this is actually part of the styloid process. So I might choose F7 again, hold Control. You'll see the cursor goes to a minus, and I can click that button and deselect it. Then I can hit delete, and all those little floating pieces will go away. All right, so I'm gonna do that again, Control F to select it, and click follow advice, and it'll do its best to get rid of any mesh defects. And here it's just kind of, there weren't any defects, but you may have some. The next thing is smoothing. So you can see segmentation artifacts here where these boxes aren't super smooth, but in reality, those walls are smooth. So that might be a function that you want to do to the entire mesh. You can see a lot of these surfaces can be a bit rough. So if you want to do that, you can use Alt-R first on the keyboard. And this is a reducing step, which helps the smooth work a little bit better. You're going to choose geometrical error, which is controlling how much the mesh can deviate from its original position of 0.075 millimeters, 75 microns. And then choose Alt-S as a shortcut for smoothing. And then you have a range of 0 to 1 values. So this is kind of by experience. You can put more or less. I'll put somewhere in the middle, just so you can see the effect of those surfaces that were rough now becoming smooth. The other thing you might look for is a stair step artifact, which could occur something like here, where this is an effect of the slices themselves. So that's not actually on the bone. So I might want to smooth those parts out. And if you want to not smooth the whole thing, but just specific areas, you want to use local smoothing, which is S on the keyboard. So I pushed S. I'm going to check selection only. And click in this entity box to make it active. Click on my object, click surface. And I'll say, how big of a brush am I going to use? Maybe something like an inch in millimeters here. And then I can go up here and click on my mesh. And if this takes a long time for the computer to handle, you can do another Alt-R and reduce the mesh again. And then use S, pick your surface, and use the brush to smooth out any mesh artifacts. You'll see that reducing step actually worked a little bit to get rid of that effect. So it's pretty good. So you might want to get that surface there so you can adjust your brush and run that smoothing operation. So that's what we might do. Look for the segmentation artifacts, stair steps, and those rough looking surfaces. We might want to patch some holes in our mesh. So there is an actual hole in the outside of the maxillary sinus here called the infraorbital foramen, which is where a nerve comes out of the bone. There's a nerve path through there. So want to know where that is, we could look at our mimics and we could look at where that hole comes out, which is typically around here. Right, and we could see on our axials that there's a hole in the bone there. And then we would say, okay, we want to keep this hole, but we want to get rid of these other holes. And we'll use the marking tool, or M on the keyboard, choose our selection as the surface, click the brush, and then I'm going to use a very, very small diameter, so it's kind of just like where the mouse is. And then I could draw a big loop around the holes that I want to delete. Go up and get that one too. And I might hit delete on that one, and I mark these surfaces on the inside. And then use the plus on the keyboard to expand the selected triangles, and then use the minus to kind of bring it back. Probably get something like that, something that's close to the original one, and then delete. That's basically opening up that hole. The next thing I'll do is hit F on the keyboard, which is filling hole freeform, and then I will select the boundaries of each of those outside holes and hit apply. That'll patch the inside hole, and click the outer hole, bad contour, apply. And if you get any kind of weird issues with filling holes here, look at the angle of the triangles on the edge of that hole. Typically, you want to maybe expand until the edge of those triangles are all kind of flat and pointing toward each other, so that when it goes to bridge that, it knows to go kind of straight across. You may or may not have this tangent box checked off if you are doing a slightly curved surface, and depending on the shape of the hole, you kind of want it to be circular. You don't want to have like a peanut shaped hole. It might get confused if you're going around edges. So this essentially has a new surface. I see a couple of these bad contours left over, and I don't know where those are, so I'm just going to try and patch those, but you can see it didn't work super well. So I have this one. I'll try Control F to also fix it. See, probably the inside of that maxillary sinus is closed off now. So we'll see. You see a large number of those inverted normals that could be in a hollow cavity on the inside is getting closed. Great. And the main things I'm looking for when I fix a mesh are things that can't be fixed, like bad edges are generally something you don't want in a final part that you're going to 3D print. So you want those to go to 0. Things like overlapping triangles, intersecting triangles, those are okay. Shells are essentially like floating pieces. So that would be important for 3D printing because you want those, you don't want any floating parts of a print that aren't connected to other things. So like I showed before, you can view those by hitting F7, clicking the big object, hitting O, and then you'll see where those exist because they'll be highlighted in orange. So that's our styling process there. So if I want to like connect those two, I could try and bridge those. I think for the purposes of this video, I don't worry about that. Just get it. You can see here the condyle of the mandible is actually not in the right place. We have some of it that goes to the zygoma. So what I would do here is probably just chop off that piece of the mandible, so I could isolate it by doing show only. I can trim this off. Probably the easiest way to do this would be marking it. So make sure that only the mandible gets marked. And if it's a nice round surface, I could probably use the same tool I did before with the fill hole freeform. So I'm going to expand the selection back. Expand it a little bit more just so it kind of starts wrapping around to the top, and delete that. And we'll use that tangent to help make it nice and smooth again. Same thing with this one. Make sure those triangle edges of those surface is helping you approximate the rest of it. So make sure there's no kind of weird angles of triangles that are left over. And you can use control and draw the brush to delete some areas. So I'm going to use F and fill these contours. If I choose tangent, oops, and maybe a medium. That works super well. It's a little bit better. So sometimes you gotta play around with settings. The smooth operation was better for this mandible, so just hit undo a few times. You can do smooth on marked triangles as well. That might help fix it. You can also do local smoothing with S. Choose the surface and help shrink those areas down. You see this area has kind of weird mesh defect here, which you can use the marking tool. That hole. So you can see for smaller holes, it's a lot easier. So see for these triangles are kind of facing in a weird direction, so I'm going to hold control to select through all of the mesh and try to get rid of those. Combo on the other side. So for this one, it works better. All right, and I'll show my axle again. So if you don't want those like extra surfaces, I mean, it doesn't really matter for printing, but visually, if you're bothered by them, you can do this merge all surfaces if you right click, and that'll go over those lines. Okay. So for 3D printing, if you wanted to actually have those mandibles connected, you can connect them physically with these cylinders. So this tool create connections is pretty helpful. If you select two parts between the mandible and the maxilla, you can choose a radius where the minimum is smaller than the essentially the cross section of that area of the part. Just make sure it's small enough, or else it might not get created. Maximum length ensures that you don't have cylinders created at very large distances. So for example, cylinder, I might want a cylinder between the ramus and the zygoma here. But I might, if I'm making the anatomic ribs, I might not want cylinders between two ribs. So that can, this distance can control if a cylinder is able to go a certain distance. So for this, maybe the max is about 20 millimeters that I would want it to go. So I could put 20 millimeters. Target distance would be the distance between two cylinders. So I have one here in the condyle and one over here in the ramus, and those will be separated by, I don't know, at least 10 millimeters. So I put 10 in target distance. But if I put a very large number there, it would make one and not the other. Hit apply. You can do convert to solid so that they automatically are in the printable phase, and then you can check it out. So if that's fine, I'm going to show you what happens if you choose smaller radius. So depending on printing technology, you might want to larger or smaller cylinders. And then if you don't want some of those, it's easier to delete them than add new ones. So feel free to adjust those dimensions as you like, and you can just hit F7 and you can come in here and say, I want this one. Really, you want to actually boolean all of these cylinders together. So just that folder that you want to use, Control B is Boolean, reading apart and remove original. Click apply, and now all my cylinders are one part. This folder is empty, so you can delete it. And then I can hit F7 and click all the cylinders I don't want. This one. And hit delete. Okay. So that is what you might do in the CAD for making a part 3D printable, changing the colors how you want. If you save out STL files, they won't have colors natively applied. If you save out an OBJ from here, it will have the color that's assigned to the surface. So we do File, Export, OBJ, and then choose the file name here. So I'll choose and then choose entities and choose all the parts you want to export. It's okay to save multiple parts into one OBJ file, and in other print prep softwares, you can assign a color to each of those parts separately, even though they're all in one file. So that's pretty useful. Be aware for certain printing technologies, if you have these large cavities, like sinus cavities, you might want to put holes in there to drain out liquid resins or more easily remove support material. It just might be hard to get to. With this, the maxillary sinuses are chopped off actually, so that would be easy to wash out. And there's a big hole in the side of the skull, so that's going to be easy to wash as well. So yeah, that's some basic cleanup of segmented object and preparation for 3D printing using 3-matic. Thanks for watching.